Hello and welcome to another video. In this video we're going to be working on most profit assigning work. And in this one you have N jobs and M workers, and you're given three arrays: difficulty, profit, and worker, where you have a difficulty and a profit, which is the difficulty and profit of a job, and the worker is the ability of a worker to do a job. And multiple workers can do one job, but each worker can only do one job. So if there's a job that all the workers can do, that's the most profitable. They can all do that one, but each worker can only do one job total. Yeah. And so you want to determine the maximum profit, so let's take a look. So in this first one, the difficulties and profits are matching. So like the harder difficulty is worth more, which isn't always the case. So in that case, you just want to give every worker the highest difficulty they can. So worker 4 can do task with a difficulty of 4, which is worth 20 points. Worker 5 can do difficulty of 4, which is worth 20 points. Worker 6 can do task with difficulty of 6, which is 30. And then 7 will do task with difficulty of 6, which is 30. So you get 30 times 2 plus 20 times 2, so you get 100. In the second one, you can see that, actually, does this match? Yeah, so you can see that here, the hardest job isn't always the best paying, right? So this is the hardest job is only worth 24. So this first worker that can do 40 can't do any jobs. I guess it doesn't really matter, but this worker can't do any, this worker can't do any, this worker can't do any. But let's say worker had actually, a number of like 100, they can pick a job. They're not going to want to do the most difficult one. They're going to want to do the most profitable one. And that's kind of like the main thing of this problem. So you want to figure out for every worker, what are all the jobs they can do, which one's the most profitable, and just do that one. And how do you do this efficiently? So it's actually pretty easy. What we can do is we can actually sort our difficulties and our workers. So let's kind of walk through what this is going to look like. So we can basically make an array of tuples, or like a 2D array, where we have a difficulty and profit combination sorted on difficulty. So let's show what this looks like. Let's say we have this and another one. So this will be our combination of difficulty and profit. So in this case, it's sorted, so I'll just leave it like that. So let's say our difficulty is 2, 4, 6, 8, 10. Now let's just change our profits, because like I said, our profits won't always be greater as the difficulty increases. So let's say we have 10 here, 5. Actually, let's just write it, make it a little bit cleaner. So 10, 5, 15, 2, then like 1 or something. And let's change these as well, just to make it a little bit cleaner. So 10, this is good enough. Okay, so essentially what we can do now is we can actually sort our workers as well. So our workers will be 4, 5, 6, and 7. So let's just write those on the side somewhere. And we only need 4 of them. Okay. So if we actually sort everything like this, let's clean this up still. All right. So if we actually sort everything like this, then we're not going to need to do extra work, because like if one worker can do some tasks, then the next worker is going to be able to do at least all of those tasks, if not more, right? So for example, so let's write this down. So this is difficulty joined with profit. And this is our workers. So if worker 4 can do all of these tasks, that means worker 5 is gonna be able to do all these tasks as well. You just might have to add a few more. And that's the idea. We can traverse our workers, figure out what tasks the first worker can do, and then we can just add on to those. We can figure out, like, can the next worker do the next task, and so on. So what's this gonna look like? So let's take a look. So we'll have 2 pointers, one over here and one over here. And so for this first worker, we're going to say, okay, can they do this task? If they can, let's go to the next one. So they can do this one and they can do this one. So we can point over here. And then we can just say, we can actually point to the next available one, and then we can check if they can do that. But as we traverse these two, we're going to keep track of the maximum profit we've seen, because like I said, you're not going to want to do the task that's the hardest. You're going to want to do the one that's the most profit. So over here, we'll say we can do this one. So our best profit is 10. We can do this one again. Our best profit is 10. And here, we can't do this one, so we'll just leave it here. So our best profit so far is 10. So this worker 4 is going to get 10 profit. So we have a 10 here. Then we move on to the next worker. And can this worker do this task? No, they can't. So they're going to get 10 profit as well. Can this worker do this task? Yes, they can. So then we will maximize our profit. So we have 10 and 15, so our best is 15. And then we will update our pointer. Can that worker do this task? No, it can't. So this worker has a profit of 15. And then for this worker, can they do this task? No, they can't. So they have the same profit of 15. And so our total profit is 50. That's kind of how you do it. You can just sort, and then for every worker, you can just add more tasks. Like for the current tasks, can they do it? Just keep adding tasks until they can't. Keep track of the best profit seen so far, and then for that worker, that's the answer. So pretty straightforward, just a bunch of arrays and sorting and things like that. Okay, so let's code that. So first, we're going to want to make an array of tuples of difficulty and profit and sort it on difficulty. So we can say array, maybe like tuples or something, or pairs. Let's just call it pairs, equals new array. And so the number of rows will be the profit length or difficulty length, same thing. And each one will have 2 items in it. Okay. Now we have to actually fill this thing out. So we can say for int I equals 0 is less than profit length. We can say pairs I is 0 equals difficulty 0, or difficulty I, and pairs I1 equals difficulty, or not difficulty, profit. Okay, so we have an array of tuples pretty much, and now we're going to be able to, and now we have an array of those, and now we need to sort it, so we need to sort. And so you can't just do a normal sort. Like I think if you do this, this will error out because you have to actually give it, at least I think this won't work. We can see what happens. But I believe you have to give it a custom comparator. I'm not entirely sure. I guess we'll find out. Okay. And we have to sort our workers. Okay. So this might have some kind of default sort. We'll see if we get an error. So now we have to keep track where in the pairs we're at. So we'll just have an index. And we'll keep track of our best profit, maybe. Okay, and then our total profit. That's all we need. So now we're going to loop through our workers, and then for each worker, we're going to see how many of the pairs we can consume, and then get the total profit. So let's do that. So we'll say W we're in workers. So while I'll just say while P is less than pairs length. Yeah, while P is less than pairs length, and the worker number is greater than or equal to pairs at index P, then we can consume this pair and go to the next one. So to consume the pair, we can say, let's see, we can say best profit. Oh, this is best, so pairs are in pairs. This is at index P. We actually want to look at the difficulty, which is at index 0. So best profit equals the maximum of our old best profit and pairs at P1. Like this, and then we can increase our pair here, increase the index. Okay. Yeah, so we do that. So for every worker, we just consume everything we can. This should be worker. I don't know what they called it. Maybe it's just better to rename it. Okay. So, yeah, so now that we did that, now we can just get the result here. So we can just say total profit plus equals best profit because best profit is going to be the best available profit so far, which is what we're going to get for the worker. And then we can just return best profit at the end. So let's see if this sorted correctly or not. Sorry, return total profit. Okay. Yeah, this is what I figured. So you can't sort a 2D array just by doing sort, but what we want to do is we want to sort it on the first variable, which is an integer. So you can just say AB, and then you can just do integer compare because they're integers, A0 and B0, and that'll work, I believe. Okay, there we go. So it's kind of convenient. Lambda function in Java. All right. And if they were doubles, you can do a double compare, string compare, or write your own comparison function. All right. And if you wanted to do like reverse order, you can just do like negative and things like that. So this does work pretty good. Okay, so time. So this is, so we're sorting the difficulty and the profit, which is the same length. So let's call that like n log n. We're also sorting the workers, so let's call that like m or something, m log m. And then we're going through the profit once and the workers once. So it's like n log n plus m log m plus n plus m. Space is O of n because we are combining the difficulty and the profit into a tuple. So that's going to be length difficulty, and there's going to be 2 items in each one of those. So it's basically 2n space. Yeah, curious how this did. Let's find out. Okay, so it doesn't tell you the other one, which is interesting. So I guess it might not give you complex complexities. Maybe it's only just like n squared and like log n or something. It doesn't give you like multiple terms, which is interesting. What this one? Okay. And yeah, it's gonna be all for this one. Hopefully you liked it. If you did, please like the video and subscribe to the channel, and I'll see you in the next one. Thanks for watching.